Okay, just now we have a look at the linear absolute equation, and then we have a look at the quadratic equation, absolute values equation. So now we are looking at the more tougher question, which is rational inequality and absolute values. Okay, so given to us 1 over 2 minus x is greater and equal 4. So this is basically, we can write it as this. Okay, so we solve one by one. Okay, 4 bring to the left will give us negative 4, and then okay, we want to equalize the denominator here. Okay, so we expand. 4 times 2 will give us 8. So 1 minus 8 will give us negative 7 here. Okay, and then we expand of negative, positive, so 4x. Okay, so we get 4x minus 7 over 2 minus x greater and equal 0. Okay, we've done the first part. And let's look at the second part here. Okay, negative 4 we bring to the left, becoming positive. Okay, again we want to equalize the denominator, therefore we expand 2 minus x with 4. So 4 times 2, 8. 8 plus 1 give us 9. 9 minus 4 times x will give us negative 4x. Okay, so here we have 4x minus 7. Here we have 9 minus 4x. Okay, let's say I'm using a table sign method. So the case just now given to us 4x minus 7 over 2 minus x. So first we have to find the x values. Okay, by equating 4x minus 7 equals to 0. Therefore we get x equal to 7 over 4 and x equals to 2. Okay, and then next step you will write all the factor here for x minus 7, and then the bottom factor here 2 minus x, and the combination of the two factor. Okay, and then you may write at the line here, okay, according to the smallest number to the left. I am going to show you the fastest technique on how to insert the sign on this table. Okay, but you have to make sure that you are choosing the right factor with the right x values. Okay, for example, for x minus 7, the x values is basically 7 over 4. Okay, so 7 over 4 here. Okay, so this is our borderline. Okay, let's say we are taking any number that is greater than 7 over 4. For example, 2. Okay, so when we substitute any values here, 2 times 4 will give us 8. 8 minus 7 will give us 1, which is positive. So we basically can straight away put positive and positive over here. Okay, and if we substitute any value that is smaller than 7 over 4, for example 0. 0 times 4. Okay, 0 times 4 is 0. Okay, 0 minus 7 will give us negative. So we're gonna put negative, positive, positive. Okay, next, the second factor, 2 minus x. So 2 minus x, the pair is x equals to 2, which is over here. Okay, let's say we are taking any numbers that is greater than 2, which is 5. So 2 minus 5 is negative. So we're going to straight away put negative over here. Okay, and this has to be one group. Okay, this has to be one group. If this is positive, this also has to be positive. But you have to check first lah. Okay, take any number that less than 2, which is 0. Okay, so 2 minus 0 will give us positive. So positive, positive. Okay, Okay, so negative times positive will give us negative, positive times positive will give us positive, positive times negative will give us negative. Okay, look again at the question. They want y is greater than 0, meaning that they want the positive. Okay, that's only for the case 1. Okay, let's look at the case 2. With the function 9 minus 4x over 2 minus x. Okay, and then you fill in the table, okay, the factor 9 minus 4x and the factor 2 minus x and the question itself. And then you're gonna write here the values of x according to the smaller to the larger number. You have to put 2 here, followed by 9 over 4. The fastest technique just now, okay, you must choose the correct pair, which is 9 minus 4x is equals to 9 over 4. So this is our boundary here. Okay, so we take any values that is greater than 9 over 4. Remember that 9 over 4 just now is basically 2 1 over 4. Okay, so this is basically 2 1 over 4. So we may take any number that is greater than 2 1 over 4. Let's say 5. So 5 times 4 is negative 20. 9 minus negative 20 will give us negative. Okay? So, since this is the borderline here, this has to be the same group. Okay, let's take any values that is smaller because it is on the left of 9 over 4. Okay, smaller than 9 over 4. For example, 0. 0 is smaller than 9 over 4. Okay, so 0 times 4 is 0. 9 minus 0 is positive. So this has to be positive, positive, and negative will give us positive. Okay, again, positive times positive will give us positive, positive times negative will give us negative, negative times negative will give us positive. Okay, which column that we are going to choose? Okay, look at the notation here. Y is less than 0, meaning that they want negative. Okay, so x is in between 2 and 9 over 4. Okay. Now it turns to combine the case 1 and case 2. Okay, so the case 1 is x is in between 7 over 4 and 2, while the case 2 is x is in between 2 and 9 over 4. So since we are looking greater and or, we are finding union. And so union, our answer is 7 over 4 until 2 or 2 until 9 over 4. Okay, let's try the same example but using different technique, which is squaring method. This is the easiest method to solve the problem involving rational absolute inequalities. Squaring method use the property that if absolute x is less than a, then x squared is less than a squared. You are allowed to use this method only when you have the modulus sign on both sides. Therefore, first, we have to bring the denominator of this equation to the right. Absolute 1 greater than 4 absolute 2 minus x. And then, since we are using this definition, we can square both sides. But remember, you have to square the value 4 as well. Four squared becoming 16. 2 squared is 4 minus 4x plus x squared. And then we expand. 16 times 4 becoming 64 minus 64x. So this is basically 16x squared minus 64x plus 63. If this is greater than this function, this means lesser than 0. Remember the comparison of elephant, it's greater than ants, therefore ants is smaller than elephant. And then we factor out this equation. We will get 4x minus 7 and 4x minus 9. Okay, so x is equivalent to 7 over 4 or x equivalent to 9 over 4. Okay, bear in mind that this function here, 2 minus x, so for what, since we are dealing with the quadratic function, therefore we are allowed to use the graphical method. So 7 over 4 and 9 over 4. Small graph since the coefficient of x squared is positive. And then we're going to shade the region since y is less than 0. So we are shading this in between 7 over 4 and 9 over 4. Okay, bear in mind that our question is rational function where x never ever can be 2. Because when you're dividing with 0, the function will be undefined. Okay, so since 2 is located in between 7 over 4 and 9 over 4, therefore our answer has to stop at 2. So 7 over 4, where 2 is excluded and 7 over 4 is included, union 2 until 9 over 4. So you will notice that we have the same answer as the previous